Let's now turn our attention to the A. Now I know we just did K, but instead of doing H, I want to talk about A. And the reason I want to talk about A is because just like K, A is outside of the function. It's going to make it a little bit easier to understand. So again, I'll use our absolute value function as example. Y equals, let's say, 4 times the absolute value of x. Now, it's not usually written 4 times the absolute value of x. It's usually written for absolute value of x. But we all know that in our math, that implies this little times symbol right in there. So let's make a graph, and let's again start with our parent function. Our parent function is f of x equals the absolute value. That is the ugliest left side that I think I've ever done since the last left side that I did in the prior video. Let's try again. I'm going to start here and go this way. That's a little better. Okay. So that graph represents f of x equals the absolute value of x. Every x that I put in is going to give me a y that is the absolute value of that number. So let's build our little function machine again. Here's our function machine. And what that says is that every time I put an x in, it goes into the function machine, it hits the absolute value. The absolute value kind of spins it around and makes sure that my x becomes an absolute value. And now my x is going towards the outside of the function machine. But just before, again, this is outside the function part, outside the absolute value. Just before it spits it out, it's got to multiply it by 4. Then I will get my y value. Not until I've multiplied it by 4 will I get my y value. So what does this mean? Let's pick a particular number. Let's say that x is equal to 1. Well, I put my 1 in for x. It goes into the function machine, spins it around in the absolute value part of it. Absolute value part of it says, oh, well, absolute value of 1 is 1. So I'm going to kind of keep going out. Oh, but before I can lead out and give you a y, before I can deliver you a y, I have to multiply it by 4. Well, 1 times 4 is 4. So my y value is going to be 4. So our x is equal to 1, right there. My y value, instead of being 1, like it would have been had it only been the absolute value of x, had to be multiplied by 4, so my y value becomes 4. Well, what if I drop in a different x value? I want to drop in the x value of 2. Well, it goes into the function machine, spins around in the absolute value part of the function, still 2, absolute value of 2 is 2, headed towards the exit. But before I get to the exit, I have to multiply it by 4. Well, 4 times 2 is 8. So my y value that is spit out of this now at x equals 2 is going to be 8. Well, what if I had put in -2? Okay, -2 goes into the function machine, spins around in the absolute value part of it, becomes +2. Headed towards the exit sign. Before I can leave, I have to multiply by 4. That is also going to give me a y of 8. So -2, I'm also going to have 8. What about, and this is one that I really want you to pay attention to, because a lot of people kind of get a little bit confused here. What about if x is 0? I put 0 into my machine. Absolute value of 0 is 0. It's headed out the door. Before it exits, I have to multiply by 4. I am not adding by 4. I am multiplying by 4. Well, 4 times 0 is still 0. So my vertex, my point right there where x equals 0, is still 0. It does not move up 4. It does not move to the left or right 4. I am multiplying that value by 4 before I give you my particular y. So my vertex is the same. And now let's just do one other number on the other side of the vertex. Let's do, I don't know. Oh, we did one on the other side of the vertex, didn't we? We did -2. So my new graph looks like this. It's the same V shape as the absolute value function. If you stood me right now, you'd see me holding my hands in the air making a V. Right? It's the same V shape, but every single Y value on the parent function has been stretched by a value of 4. This one right here at 2, it's been stretched all the way up to 8. This one here at -2, 2, the Y value has been stretched up to +8. That is how the A is working. Let's look at an A that is between 0 and 1. Instead of an A of 4, I now have an A of 1/2. Now I want you to still make sure that this is in fact an A, right? My function here I'm using is A times the absolute value of x minus h plus k. I don't see an h anywhere. That would be a 0. I don't see a k on the outside over there. All I see is my A, and my A is 1/2. So I'm going to start again with my parent function. Here's my parent function. My parent function is y is equal to absolute value of x. Here's my function machine. Inside my function machine, one of the things is the absolute value of x. What I'm doing, I want 1/2 times the absolute value of x. So when I put my x into the function machine, it's going to go down here, it's going to spin around and be absolute valuetized, and on its way to the exit, just before I get my y, it's going to be multiplied by 1/2. So my y is going to be 1/2 of whatever the absolute value of x was. Okay, well, if I put in an x of 2, the 2 goes into the absolute value machine, spins around the absolute value part of the function. It's still 2. It's on its way out. Before it gets out, it has to be multiplied by 1/2. So where x equals 2, on the parent function, absolute value of x, it was 2. But before I can spit it out here, it has to be multiplied by 1/2. 1/2 times 2 is equal to 1. So it's going to be 1. What about the value of, let's erase this here. What if I put in a value of -4? Okay, -4 is my x. That goes into the function machine. It spins around in the absolute value part of the function. Oh, it becomes +4. And it's making its merry way towards the exit, but before it can go out, it has to be multiplied by 1/2. 1/2 times +4 is 2. So my y value is going to be 2. -4, 2. What if I put in 0? Okay, so that's my vertex. It's always good to check your vertex. I put in 0, into the function machine it goes. Absolute value portion of it, spins it around. It's still 0. On the way out, gets multiplied by 1/2. 1/2 times 0 is still 0. So my vertex is still going to stay right there at 0. Where x is 0, my y is going to be 0. So I can see that this absolute value graph is going to look like that. Every single y value, the y values that I have now been cut in half. The y value has been cut in half. The y value has been cut in half because I had 1/2 times the absolute value of x. So when my a is less than 1 but greater than 0, so it's a fraction. When my a is a fraction, I'm going to be squashing down the v. If you're standing here, you see my arms going down. My v is going to be squashed down. So that is what my a does. My a either stretches a graph up or squashes it down. The vertex stays the same based on a alone.